Yeah, those new ATtiny Series 1 chips got some really good features, and we thought it was worth getting ourselves really set up and tooled up to work with these. And we're going to show you exactly what that's all about. First of all, they have a 20 megahertz internal clock, which saves you using up two pins for doing a crystal and still run at a high speed. Uh, then it's also got a two-cycle hardware multiply. That's a real performance improvement. And 8-bit analog out. Finally, they decided to give us real analog out. Boy, there's a lot of people happy about that. And that's only in the Series 1 chips, not in the Series 2, by the way. And also has real hardware UART in it. So we tried the method of loading the JTAG to UPDI code into a nano and loaded into a ATtiny core chip, and that actually worked pretty well. Uploads at about 100K. Okay, so then we followed the instructions on the Github page and tried doing the serial upload and various configurations and serial boards, and well, basically none of them worked.
I'm sorry, Dave. I'm afraid I can't do that.
So then we decided let's make our own custom uploader board with a lot of handy extra features like we did for the Series 1 chips. And so with a little work and some boards made by good old JLCPCB, here's what we got. Here's a quick explanation of how our uploader works for UPDI. You load the same program you used for a Nano into a ATmega 328 chip and hook up the USB. USB changes to TTL levels, and that goes into the RX and TX, and then out of PD6 you get a resistor and you come up with UDPI. Well, that goes through a switching chip here, and it turns out that when you do the JTAG to UPDI as the programmer, the DTR line is not activated. It stays high, and that makes sure that the data will flow into the ATmega chip and program the UPDI. If you switch to serial, anytime with serial, either the built-in one or another program that does serial, the DTR is activated, pulls low, and these TX and RX lines are then switched away from the internal chip here and are switched out a pair of lines as TX and RX. What this does is it restores the serial port interface function, very useful for debugging, that you had with the Series 0 chips. It's all totally automatic, nothing you need to do. So when you're actually doing the UPDI program, it automatically goes through the ATmega 328 chip. And when you switch to the monitor or any other serial, it automatically switches and goes out these. And we found that to be very, very useful. Okay, so we got a little test program written here, signs on, hello, and each time through it updates the cycle number. Basically it puts out a dash, reads a character, echoes it out, checks as if it's semicolon, then goes back up here to re-sign on. Otherwise it just goes to loop around. So you'll see our characters echoed with dashes in between, so we know we're really talking to a live device. So let's see what that looks like when we load it. And yeah, it's pretty quick here. Okay, it's loaded in. Okay, we're going to go to the monitor now. Now watch the DTR light here. Go to the monitor, it activates DTR. And because of that, let's give it a semicolon to start with. It signs on, And if you say 1, 2, 3, 4, 5, 6, it's going to put dashes in between, and you get an extra dash every time you hit a carriage return. And let's give it like several semicolons. What happens when we send all those? Well, yeah, it activates those. So we're definitely talking to the board. Now, if we exit out the monitor, you'll see the DTR light has gone back. And just to try it, we'll just do another upload here. Now we're in the upload mode. And you see it just switches back and forth automatically. Well, I guess that's a wrap. I hope you liked the little presentation. There's a link in the notes to go get that source file and schematics, and I think I got the board. Look for anything marked UPDI, and have fun.